Okay, so first I solved x plus y equals negative 1. So
So make sure to look up on the board and see where you're at.
oh, there we go. So then you subtract x on both sides, and you get y equals 1 minus x.
Wait a second. Are we missing anything?
Negative 1.
Yeah.
And then you go to negative 1, and then you'd go down 1 over 1. Oh, so there's like a 1 right here. So it'd be negative 1 over 1. And so then you have to do the next one. 3x minus 2y.
That's what you're going to do.
And so first you subtract 3x. So you get negative 2y equals negative 8 minus 3x. And then subtract 2, negative 2.
Subtract or divide?
Sorry, divide negative 2.
Okay.
And then you get y equals 4 minus 3 over 2x.
Is that minus?
No, plus.
Okay, negative divided by negative is plus.
Yeah. And then you go up here to 4. And you go, you can't really go up, so I just went down 3, left 2. So 1, 2, 3, 1, 2.
Negative 3 over negative
1, 2, 3, 1, 2.
So what's the actual answer?
And so this is where they cross. And so it would be negative 2, 1. Okay. Chase, would you like to? Or do you want me to? Okay. Otherwise, I can come back to it, but I think you got it. All right, so number 18, guys, we're solving the system using substitution. Hey, do not forget on that problem that Mickey just worked. When you're solving a system using graphing, you've got to find the point where they intersect.
So this is substitution. Tell us what you're doing as you do it.
Okay, so I gotta get y by itself.
You're going to do x and that's 7.
Yeah, sorry.
So you're subtracting 7x from both sides to get y by yourself.
Then I have y equals.
And you wrote negative 7x minus 8. Can you write negative 8 minus 7x? Okay.
So then you want to plug that in for y. Then you distribute. Oh, that's negative. That's also negative.
So we got 4x minus 21x and then
Minus.
minus. Mark out both negatives.
Okay.
Yeah.
Dang, I did it again.
4x
Yeah. Okay. Combine like terms. So we have negative 17x equals 34 after you add 24. Yep. So then
And what do you get, guys? Negative 2? Alright, is that the final answer?
no.
We found the x, what do we need to find y? Or now? Oh, no y. So tell me what you're doing.
Then you plug x back into one of the equations.
Into that y equals negative 7x minus 8.
Yeah.
Would you draw an arrow from x equals negative 2 to that x? That bottom there, yeah. Draw that.
add 14. From y equals 6.
Okay, so if x equals negative 2 and y equals 6, the corresponding answer is 2, 6. Okay, perfect. So the big thing on substitution, thank you, is to solve for one variable, plug it into the other equation, and then once you've got one variable solved for, plug it into the other. So Chase, what I was saying, because I don't even think to do that anymore, but you're right, you plugged in x equals negative 2 right here. Guys, could you have plugged in negative 2 into either equation? Sure. What I was thinking was, just because I always do this, I plugged in x equals negative 2 right there, and to solve for, because y is already by itself, but it really doesn't matter, okay? Whichever place you plug it into, you're going to be able to solve. Okay, good. Is this your pencil? Okay, number 20, elimination. Okay, would anyone like to solve it, or shall I? All right, I'll do it. X minus 3y equals a negative 1, and negative 9x plus 6y equals a negative 12. So remember, the idea behind elimination is to eliminate a variable. Does x plus a negative 9 cancel each other out? No. What plus a negative 9 would give you 0? A positive 9? So I could, if I wanted to, multiply the whole top equation by positive 9. Okay. Now, if we look at the y's, negative 3 plus 6, does that equal 0? No, but what if this was a negative 6? Would it cancel each other out? So what if I multiplied this equation by 2? So if I multiplied all this by 2, so you actually have two different choices. Multiply it by 9 or multiply it by 2. Do I care? I don't. Which one do you want to do? Multiply by 9 or 2? All right. So let's multiply this by 2. So I've got 2x. I'm just going to write it below the other one. Negative 6y, and 2 times negative 1 is negative 2. Remember, the point is to multiply by something that'll cancel out with the other one, right? I had a positive 6. I needed a negative 6, so I multiplied it by 2. All right, so I'm going to do this. Then 6y minus 6y cancel each other out. What's negative 9 plus 2? What's negative 9 plus 2? Good, negative 7. What is negative 12 minus 2? It's like you're adding negative numbers, right? I got negative 7x equals a negative 14. I need to divide by negative 7. X equals positive 2. Now, x equals a positive 2. What can I do with that? Yes. Once I've got x equals a positive 2, I can go and take that and plug it into either equation. Which one do you want to do, the first equation or second equation? Okay, does it matter? Then I'm going to do the first. So I've got x equals 2. So I'm going to plug in x equals 2 right there, minus 3y equals a negative 1. If I had plugged it into the other one, that would be negative 9 times 2 plus 6y equals a negative 12. Either way, I should get the same y value. So for the first one, how do I solve for y? What's the first thing? Someone other than Mim's answer. What do I do? Subtract 2. So I've got a negative 3y equals a negative 3. Alright, someone different answer. What do I do now? Divide by negative 3. So y equals 1. I could go ahead and say my answer is 2, 1. I'm going to go ahead and check it. Make sure when I plug in 2 for this one, I get the same thing. Negative 9 times 2 is negative 18. I want to solve for y. Charles, what do I do? Good, add 18. 6y equals, Looper, what is negative 12 plus 18? 6? Okay. And then Boswell, what do I do? Alright, y equals 1. We got the same thing, so we're good. Okay. 22. It says sketch a graph of each system of inequalities. So remember, when you sketch a graph of inequalities, we're talking about greater than, less than. You got to think about shading above or shading below, dotted versus solid, and linear versus quadratic. Now, this one had a linear function and a quadratic. These two over here are both what? They're both what? Linear or quadratic? They're both quadratic. Okay. Do you remember the vertexes on this one? Do you remember what transformations? What does plus 3 on the inside mean? To the left 3. So if I go left 3, and then what does plus 7 mean? Up 7. So if I go left 3 and up 7, that is going to be my vertex. Okay? Now, would you shut the window, Brandon? Shut the blinds. Okay, now there's a negative in the front. What does a negative do to my function? Yes, it flips it. Okay, so normally a parabola looks like this. Our parabola is going to look like that, right? Okay, it's going to open down. Now, how could you use your calculator to graph this function? Guys, how can you use your calculator to graph this? You could go to y equals and type in that equation, right? So you could go to that, and then you go to second table and plot the points. Yes? Can I remind you of the pattern? Hey, what's 1 squared? What's 1 squared? 1? What's 2 squared? What's 3 squared? And 4 squared? 16, and then we keep on going from there, right? Okay, now, if this is the perfect square, the quadratic, and all I did was move it to the left 3, up 7, and I flipped it over the x-axis, doesn't it still have this pattern, this shape? Yeah, all I did was transform it, move it. So instead of going over 1 and up 1, instead of going over 1 up 1, over 2 up 4, over 3 up 9, and over 4 up 16, I'm going to go over 1 but down 1, over 2 but down 4, over 3 but down 9. So I'm going to just do that pattern, and I don't have to worry about using my table. To the right 1 but down 1 on both sides. To the right 2 but down 1, 2, 3, 4, and then mirror image. To the right 3, 1, 2, 3, and down 9, that puts me at -2. So I'm going to just follow that pattern. Over 1, down 1, over 2, down 4, over 3, down 9, over 4, down 16. 7 minus 16 is that -9? Okay. Puts me at -9. Now, remember, if you are unsure about that, you can use the table. Y equals, type it in, and then go to second table. Okay. If this says, what do you say, dotted or solid? Solid, because of that equal to, right? When I see that line, to me that means the line, you know, so I'm going to go ahead and sketch a curve through that. Now it says less than or greater than. I would say 1 is less than 2, right? So less than, which means I go to my vertex and point the arrow up or point it down? Okay. Which means I should be shading somewhere inside this parabola, right? Okay. So now let's graph the other one. Okay. Where is this right here? What does that -4 mean? Go to the left 4. What does that mean? Oh, I don't know why I said that. +4 means go left 4, right? And then -2 means go down 2. So I'm going left 4 and down 2. Left 4 and down 2, and that's my vertex. What's the number in front? 1. So the pattern is this one right here. From that point right there, I'm going to go over 1 up 1, over 2 up 4, over 3 up 9, as much as I can see, and then I'll be done. If you can remember the pattern, it's a whole lot faster than having to use the calculator and plot points, okay? So I'm going to go over 1 and up 1 on both sides. Why does it go up instead of down? Good. There's no negative in front. There's no minus, so it is positive. Okay. I went over 1 up 1. I go over 2 and how much? 1, 2, 3, 4. And then I go over 3 and go up how much? 9. That puts me at 7. Am I going to be able to see the next point? No, so I'm just going to go ahead and sketch. Solid or dotted? Yes, dotted. So there we go. Now, does this say less than or greater than? Less than. So I'm going to draw from my vertex pointing down all around my parabola. I point down. So I need to be below both parabolas, right? So where's my solution set? It's got to be below this parabola, so it can't be any of that graph, right? But it also has to be below that parabola, so I'm thinking everything underneath, inside this first parabola, but underneath this second parabola. And there we go. How many of these systems are going to show up on your test? Rye's going to have about 10, but the rest of you are probably going to have 1. Sorry, Rye. I'm just going to give you a harder test. But there's only going to be 1. Now, do you think that the parabola is going to be more like this one or more like this one? I'm thinking more like the second one. I want you to be able to find vertex and do left and right and all that. Do you think I'm going to have 2 parabolas or a parabola and a linear? I don't know. We'll see. I haven't really decided on that, but as long as you can graph one and then the other, you'll be fine. You'll be fine. Okay. So the last question, yeah? Okay, linear programming. So remember, the point of linear programming is to graph all of these inequalities. You solve for y in each case, okay? So we had to solve for y in 3 different equations. We had 2 simple ones. You sketch it. Once you find all the intersections of your region, then you plug those into your objective function, and then you find which one's the max, which one's the min. Is this a long problem? Yeah, is there going to be one like this on the test? Yes, okay. Probably not going to have 5 equations, but maybe 4, maybe 3, okay? All right, so this first one is x is greater than or equal to -6. Okay, x is greater than or equal to -6. There's no y to solve for, so let's just sketch that. Guys, I have some people that still draw the wrong kind of line with a problem like that. X is greater than or equal to -6. All you know is that all the x values have to be greater than or equal to -6, right? So if this is the x-axis, and there's -8, and there's -10, -9, -7, you can't be those, but you can be everything greater than. Does it make sense that you would say all of these, so it's a vertical line? If you went through the x-axis a horizontal line, it wouldn't be telling me anything special about -6 on the x-axis, because it goes through all of them. Okay, solid or dotted line? They're all solid, don't worry about that. Okay. So it says greater than or equal to, right? Yeah, 2 is greater than 1. It's got to be greater than. So we are talking about going to the right. Okay, so there's my first one. All right, now the second one, I need to solve for what? I need to solve for y. So I'm going to write down x plus 3y is greater than or equal to -18. And you're right, I'm going to start solving it for y, and the first thing I'm going to do is subtract the x. So 3y is greater than or equal to -x minus 18, or -18 minus x. Now what? Divide everything by 3? Everything by 3. So y is greater than or equal to? Good, there's a 1 right there, negative 1/3 x minus 6. Shall we go ahead and sketch that? Y is greater than or equal to negative 1/3 x minus 6. Okay, so I'm going to graph that one right there. All right. Okay. So, negative 6 on the x or the y-axis? That's a y-intercept, right? Do you know why I'm still saying that? Because I still got people that accidentally put it on the x-axis. That is a y-intercept, so I go to y-axis, negative 6. And what's my slope? Down 1/3. So I'm going to go down 1 to the right 3. It's a negative and a positive, so I go down and to the right. Negative 1, positive 3. Down and to the right, down and to the right, or up and to the left, yes? Now, I'm going to keep going, but technically I know that I have to be past this orange line, so I didn't have to keep going. Now, it says greater than, true? So arrow's pointing which way? So start on the line and draw your arrows pointing up. I got some people that accidentally draw a line and then they draw the arrow below it pointing up. That's not how we do it. From the line pointing up. Okay, so there's the second one. Now the next one is x plus y is less than or equal to 6. So I need to solve for y. What do I do? Good. Subtract x. Y is less than or equal to negative x plus 6. Y is less than or equal to negative x plus 6. What is my y-intercept? Positive 6. What is my slope? Okay, that is negative 1/1, and that is a negative 1 and positive 1, or up and to the left, yes? So down and to the right. I'm going to keep going because I don't know when I'm going to need to see the intersection, and I'm going to go the opposite this way, up and to the left. Now it does say less than, so which way should my arrows be pointing? Okay. The next one is 2x minus 3y is less than or equal to 27. The first thing I do want to do is, yes, subtract the 2x. So I subtract 2x from both sides. What am I left with? A lot of people forget this negative. It is a negative 3y that I'm left with is less than or equal to a negative 2x plus 27. All right, tell me about if there's anything special about this. Good. Okay. If you divide by a negative, you have to remember to flip this inequality. Okay, now, what if you forget? Well, when you sketch this line at wherever it is, and we end up drawing arrows pointing in the wrong direction, you're going to see pretty quickly that that doesn't really match up with what the shape should look like. And so that's kind of a clue that something's wrong. Okay? And for me, if I were you and that had happened, I would probably just switch it just because I knew it had to be wrong. So negative divided by negative is positive, so that's a positive 2/3. 27 divided by negative 3 is a negative 9. Y is greater than or equal to 2/3 x minus 9. So I'm going to go to negative 9 on the, oh, let me put it in here. Okay, so negative 9 on the y-axis, and 2/3 is my slope, up 2 and over 3, up 2 and over 3, up 2 and over 3. It says greater than. Now, if I had pointed my arrows down, you see how it wouldn't have really made sense because it seems like everything is pointing into this region right here, and I would have been pointing down right there. So that's kind of a clue that something's wrong. Okay, I've got one more. Negative x plus 2y is less than or equal to 6. Okay, good. Let me partition these off real quick. So, you're right, I am going to add x to both sides. 2y is less than or equal to x plus 6. Okay. I'm going to find a color. So divide by 2. Y is less than or equal to 1/2 x plus what? 3. Y is less than or equal to 1/2 x plus 3. So I go to 3. And I have a slope of what? 1/2. So up 1 over 2. I'm not going to keep going in the direction left, 1 down 2. Greater than or less than? Which one? Less than? So does it make sense, the region that we're dealing with? Guys, if you graph a function and they don't meet at a perfect line, then something is wrong, because they should always meet at a perfect line, okay, or a perfect point. The way that I create them, it should. It actually takes a while to create these, but... Okay. Now what do I do? I have 1, 2, 3, 4, 5 vertices. So the first one is, that I'm going to write down, -6, 0. And then -6, -4. 3, -7, I agree. 9, -3. And 2, 4. Okay, those are my vertices. What am I plugging them into? The one that has both x's and y's in it, -2x plus 3y. So I'm going to plug this into -2x plus 3y. Okay. -2 times a -6 plus 3 times 0. -2 times a -6 plus 3 times a -4. -2 times 3 plus 3 times a -7. -2 times 9 plus 3 times a -3. -2 times 2 plus 3 times a 4. You don't have to write this out if you just type it in your calculator. I'm going to go ahead and write it out so you can see what I'm doing. So -2 times -6 is, I agree, 12. 12 plus 0 is 12. That's a positive 12. And that's a -12, so what's that? 0. That's a -6 and a -21. That is a -18 and a -9. And a -4 and a positive 12. Okay. So my max is what? Sorry if I was kind of awkward on that. It's fine. Yeah. The max is 12 at what point? Max is 12 at -6, 0. And then my min equals a -27 at 2 different points, right? 3, -7, and 9, -3. Okay? And that's the last problem, right? Okay.